Hey there, welcome back. My name is Varun Srivastav and today we are going to start with data structures. So in the last video we coded runtime analyzer. We ran that analyzer to compute the different runtime for sorting algorithms and we came to a conclusion that bottom-up merge sort is the fastest. Today we are going to start with data structures. And the first data structure that we are going to choose is stack. Well, stack is very easy to understand and visualize. And we call them stack because we put one thing on top of the other. And you might have seen stack of books, stack of cards. So stack is very important data structures in computer science. Heard of stack memory? Well, that is where all your function call goes. Other implementation would be if you want to track a move in a game, then stack would be a good implementation for that. Or you want to track is the operations that you have performed, you can put it into a stack and then you can pop out it later in the same order. Browser history is again a very good implementation of stack. Every new page that you visit is pushed into the stack and whenever you press the back button, it pops out that page. That's how it keeps a track of all the pages that you have visited so far. Head back to our IDE and welcome back to my IDE. So here we're going to create a package and we're going to name it com.code with varun.datastructures. And here we are going to create another package called stack. Inside that we need a class stack. This name might collide with the one that we have in Java. So, and every time we create a class, we create a test class for it because we are doing a test-driven development here. And before each is used to set up, as you remember. And what we want to set up here? We want to set up a new class, stack. And this stack is going to be a field in this class. So I can access that field from anywhere in this class. After each will trigger after every test, which we use for cleanup. So once we have ran the test, we want our stack to be null. Not required in this example, but I'm doing it as a good practice so that the state from one test case doesn't mix up with the other one. That's useful. And then we will create the actual test. It should push item to the top of the stack. Then I will have another test case. I'm just writing it so that you have a sense of the direction where we are heading towards. So in stack, there are only two operations, push and pop, and therefore we'll have two test cases. It should pop the top item from the stack. Cool, so our stack will have push. In this case, our stack is not supporting any particular object type, but we can do it really easy in Java by using generics. So we'll say that this stack should contain only integer objects. Currently, I do not have this, so I can change the field stack or change the signature to match that. Whichever type I pass from here, it should create a generic type stack for that particular type only. Now we can input 1 and then we can also push 2 and then maybe 3, 4, 5. Let's put 5 numbers in the stack. Great. Now this push method is going to be void. It is not going to return us anything. Now comes the assert part. So how can we assert that the item has been pushed into the stack? We can call something like stack.size. And it should give us the number of items it currently holds. So we can assert on that. Assert equals 5. Since we have pushed 5 items, we expect the size to be 5. Import static method. And now let's go ahead and create this method. See, IntelliJ is very intelligent actually. It automatically detected the type of the input that we provided it and it automatically replaced it with this T. Great, you don't have to type a lot. Now we want this to be an item because this is not specifically numbered. It could be anything. It could be of any type. There are two different implementations for it. One, we can do it with ArrayList or simply array, but that is, again, it's going to be a bounded thing. You cannot increase the size of a stack, and if you do, then you'll have to copy every item to other and the complexity will increase. Then there's another way where we are going to create the objects dynamically and link them together, just like a linked list. So for that, we need a node class. Let's go ahead and create a node class here. And this node class will contain the items of the same type. This is t value, and then the next node. And with this data annotation, Lombok will add the getters and setters for us, so we don't have to do it ourselves. That's pretty handy, right? Now we'll head back to our stack class, and we know that we want to create the item. So first of all, we have to check if size is 0. Currently, we do not have a size variable, which I will create pretty soon. So if size is 0, it means that this is the first item that we are inserting in the stack. It means that our stack is empty and we have to create a new node and insert it. So we'll create a new node of the same type and insert it here. And we want the constructor as well. For that, I can use another annotation, all args constructor. So this will give me constructor here. The first item is going to be value, and the second item is going to be the node where I want to point. Let's create this top node here in the field. We'll keep track of the top node. So anytime if you're going to perform a push operation or a pop operation, all you need to interact with is the top item in the stack. Now we are going to create this variable, and the size variable is going to be created once with one object of stack, and it will stay there till the end, till the stack is destroyed, and it will start with 0. So our push functionality should work fine. Also, one thing to remember, whenever we push, our size should increment by 1. That's how we're going to keep track of the number of items which are present in the stack. Now let's head back and run our test case. Yep, we also need this method. Here I'm going to return the size. Let's see if this pass or fail. So with me, it fails always for the first time. Well, I'm improving. Let's move forward and create functionality for pop. Let's copy this one. So now we have 5 items. How can we see what is the top item on this stack? So let's create a test case for that first. It should peek at the top item, and I'll paste this. Then I can assert the value of the top item, which is going to be 5, because 5th item was inserted last, so it was last in, and last in should be the first out. So whenever we peek the top of the stack, it should be the item which was last pushed into it. Peek in the stack. Peek will return the item value, so which is t in our case. So it is going to return the value, which is t, by the way, and we are going to make it stack.peek. So this will give us 5. This should give us 5. Let's see if it is the case or not. Great. We are doing great so far. in one go. Now we have to pop this item. So while popping, what we have to keep in mind is that once you pop the top item, the second item should become your top node and size should decrement by 1. So let's pop the item. So top item is 5. So when I assert on the top item, it should be 4. So stack.peak, so it should give me 4 back. Let's create pop-up. This will give us the next node, or we can call it second node. That would make more sense because this is always the first. So our top node is going to be the second node now. And it's done. Let's see if it works. Great. Let's pop some more. Now we have popped 3. So we have popped 5, 4, 3. So this one should be 2. Let's run all the test cases together. Awesome. So this is how you can code a stack. I hope you enjoyed this video and you will join me for the next video, which is going to be queue. I hope to see you in the next video. Till then, bye-bye.